Hello everyone, and welcome to this webinar on Bluetooth Mesh technology. My name is Eirik Midttun, and my plan for this webinar is to take you from zero to hero on Bluetooth Mesh technology. And then we'll talk about what Nordic offers regarding Bluetooth Mesh, both in software and SoCs. So to get started on what Bluetooth Mesh is, let's look at the picture on the screen. I picked this screen because it illustrates the most important use case for the Bluetooth Mesh specification, which is lighting and LED lighting in particular. It's also a public space, so we are talking about professional lighting rather than home or residential lighting. And as we'll see through the webinar, lighting is more or less a start for something bigger. So we'll come to that soon enough. And if lighting is not the thing you're looking for in this webinar, this is a general technology. It has its certain strengths and weaknesses. So the goal is for you to learn what it can and cannot do, and you decide if this is the right technology for you. So let's start with looking at where Bluetooth Mesh is in the world of Bluetooth. So most people who know Bluetooth from the consumer world know the audio streaming solution, which is based on Bluetooth Classic. The other Bluetooth that people might know about is the Bluetooth Low Energy, which is used in wearables and gadgets connected to your phone. So that's a technology that was introduced in Bluetooth 4. And if you connect to your phone, it's a point-to-point technology where you connect directly to your phone. At the same time, they also introduced locationing services, which is based on a broadcast where there is a transmitter and any number of receivers. And what is new in Bluetooth Mesh is a new topology implemented with the profile that allows a mesh topology. And the solution area for this technology is device networks. So we talked about data transfer is a point-to-point, and I just also want to mention there's audio streaming also coming to Bluetooth Low Energy, covering all major solution areas. So what does this look like from point-to-point to mesh? So it's based on Bluetooth LE and only LE. It's a network technology that allows many-to-many communication, and the goal is to cover whole buildings, and it does so by managed flooding. So I've done a little illustration here to show the flooding. So imagine this is a node that transmits a signal. The nearby nodes will receive it, and he's not going to relay that message to other nearby nodes. And in this way, it gradually floods the whole network. And the managed part is various techniques such as time to live or remember the packet so it doesn't bounce back again. The goal is to have a smooth flood of the packets through the network without creating any problems related to flooding. I'll also give an introduction or repetition of the roles in the Bluetooth Mesh network. So you can start by defining as a node. So that's the most basic implementation you could do of Bluetooth Mesh. It enables you to communicate with other mesh nodes. And for this network to work, you also need relay nodes. So relay node is a node that can receive a packet from another node and relay it, creating a hop, so the message can spread through the network. This technology needs to scan more or less continuously, and it's not suitable for battery operation unless you have a very large battery or want to change the battery very often. So typically these are connected to mains power, and in the lighting this is not really an issue, but there's also a need to connect, for example, battery operated sensors. So for that there is the low power node. which can turn off the radio and switch it on at intervals that lets you conserve the battery. And for that to work, it needs to communicate with a friend node. And friend node is a node that can store messages for a low power node. So if you want to send a message to a low power node, it will first go to the friend node, it will keep it in a cache, and the low power node will sort of check its mailbox and ask at regular interval if there's a message. And that's how you get the message to a low power node. A friend node needs to scan continuously like the other nodes in the network. So the low power node can actually send messages at any moment to a friend node, and the friend node would relay it to the network. Another thing about Bluetooth, which is a big advantage, is that technology is in everyone's pocket in form of a mobile phone. But this the mesh feature is based on advertising, and most phones do not support this mode of communicating. So if you want to communicate the network, you need to establish a point-to-point connection, and that you can do with a proxy node or a node that implements a proxy node role. So that allows you to do a connection with the network, with the phone. It can be a phone, but you can also use a GET proxy to communicate with another GET node in another way. So that's a role overview. I will touch upon this later in the presentation. So this is the purpose of this slide is just to get you familiar with the vocabulary when I talk about the different roles. So an important thing to understand about Bluetooth Mesh is what it was designed to be, and as a consequence, what it was not designed for. But these things on the slides are the main design criteria. It's reliability, scalability, security, and speed. So reliability comes from multipath transmission, which I will illustrate on the next slide. And another thing is designed to be gateway independent. So depending on the use case, you may or may not want to use the gateway. But the thing about this technology, if your gateway is lost, the network will still operate and function as intended. So the operation of the network doesn't depend on the gateway being there or not. If you remember the first slide, I also there was also an illustration of the frequency band. And it shows some highlighted channels, which is kind of designed to dodge the Wi-Fi networks. Though that thing and other design decision done with the Bluetooth LE radio PHY in itself makes it a very reliable transmission channel. So when the all things adds up, you get a very reliable network. On scalability, it's we're talking about the node count and also the fact that it can cover large areas, such as entire buildings. Security, the security is built in. You can't switch it off. You have to have it in. It supports multi-level encryption, which I'll talk about, and also privacy. And this was a deliberate decision to make sure that when you have a Bluetooth Mesh installation, it is secure enough to support a large number of use cases where this is important. So it is actually a vision to make this a reliable technology that can be used for all use cases. And that is the fast. So that's mainly about the responsiveness and the fact that it's based on multicast. So it's related to this flooding mechanism. What it does not mean is high bandwidth. So you cannot transmit a large amount of data on this network, but you can reach nodes quite fast. So to go on with this, there are two really key concepts to understand in these technologies. One is the multi-hop, the message relay. So this is what extends the range. So if you have a light switch, for example, it needs to be in RF range, which is 10 to 30 meters, depending on your design, to a nearby node. And the multi-hop solution, which retransmits the packets, gives you near unlimited range. Technically, there's a limit of 126 hops, but with 3 hops, you easily cover an entire office floor. So there's basically no limit to this. So it gives us also range, but it also lets you get around physical obstacles. So if there's instead a node here is a concrete wall, you can find a path around it. The second part is multi-path, and that is kind of the reason why this is a reliable technology. So here I've drawn a light switch and a light bulb, and this is just 2 possible paths that a message can take. So it can reach 2 nodes here, they will retransmit, and these 2 nodes will retransmit signals. So if any of these packets are lost, there's always another path, and I can draw another one here, for example. So there's quite a large number of paths that the message can take. So this redundancy creates the reliability needed in this network. Also note that I've designed one light bulb, but if you look at the ceiling in your office, you see plenty of lights. So this flooding mechanism is really ideal for when you want to switch on or control a large amount of lights, and you want to do that at the same time. Which brings us to another point, which is the group addressing and the publish-subscribe concept. So instead of addressing individual nodes in a network, there's a definition of a group addresses and also virtual addresses, which provides the same concept but a nearly unlimited address space. Here we see an example of a building where you have multiple lights, but somewhere in the hallway, somewhere in the kitchen, somewhere in the dining area. There's one in the bedroom. And instead of addressing them individually, you assign them to a group address, and the switches that want to control the hallway, for example, will publish to that group address, and the lights that want to be controlled by those switches will subscribe to that group address. So the decision on switching on and off light will be taken at the node level. So when this switch switches on, it will publish to the hallway address. All the lights in range will receive the message that you should turn the lights on, but only the subscribers to the hallway address will actually turn it on. And as you see, the small combination, you can have more than one switch controlling a certain group, or you can have you can subscribe to more than one to more than one group address. So maybe the kitchen can have lots of lights on while you're cooking, but if you want to dim the light in the dining area, you can also do that on a nearby light, which is in between the kitchen and the dining area. So this is built into the standard itself, and this is actually how the network operates. There's also a high focus on security, as I mentioned. So I'll show 2 illustrations on how this looks like in the standard. So this is a payload for a Bluetooth Mesh packet, and you see the payload is encrypted. It obfuscates the header, and it has a sequence number, so it has some uniqueness to each packet, so you cannot do replay attacks. We also add the message integrity checks, and from this illustration, you can also see one of the how the design decisions affect other parts. So quite a lot of the entire payload in the advertising packets is used for for the integrity check and for the sequence numbers, which reduces the application payload, but it's a choice that's made to focus on security. This yellow part here, that is the encrypted payload, is encrypted by a network key, and you can have more than one. And this is the first level of encryption, and the application payload is again encrypted by a application key. And this makes it possible to encrypt, for example, the lighting system differently from the door locks. So if the lighting key is compromised, your door locks are not compromised. So this allows you to combine use cases with various security requirements, and it adds flexibility to the solution. The goal is actually industrial grade security. So multi-level encryption, privacy by obfuscating the source address and encrypting the destination address. It's built from ground up, so we protect against brute force attack, replay attacks by the sequence number. There are authentication methods that protect against man in middle attack, and there's a procedure to unprovision decommission nodes, so you avoid trash can attacks. That means you take out a node of your network and you put it in trash, and the attacker will try to extract the network keys and attack your network. So you can actually prevent that node from entering your network again. And the security is a continuous process. So on each release, there is we look in Bluetooth SIG how we can improve the security. So this is meant to be stable for the future. I picked an illustration here. It's a light panel from Delta. It's the first product to receive IoT security rating from UL, which is a standards certification organization. So it means that this security is also recognized by certification bodies. There is one question I get quite often when I talk about Bluetooth Mesh technology, and that is how many nodes can you have in a Bluetooth Mesh network? And while the technical answer on a definition network is 32,776, the answer is that it really depends. Depends on the bandwidth requirements, if it's a sensor network or a lighting control network, and so on. This is usually an invitation to an interesting discussion about the system design and how to apply the technology. But for many other customers, they just want to know a number. And for that, I will give you one. So here's a picture of the current record holder of the largest Bluetooth Mesh lighting network. They started out with 3,685 mesh nodes, but it got expanded. So the current number I got was 3,923. The first nodes were light controllers with presence sensors and ambient light sensors integrated. The office is in Minnesota. It spans over 17 floors. And this project was done by EMC, which is a contractor. Silver is providing the software and software tools, and McVong International is a company that provides the light controllers. And this runs on the nRF52832. So one more key concept to cover, which is the Bluetooth Mesh models. So this is what introduces application layer concepts in the Bluetooth Mesh specification. So the models are designed to be lightweight, backwards compatible, and they're also designed around a distributed topology. So on the illustration on the left, you'll see a light node and a switch node. Light node is an example of a node that had state. So the state is either it's on or off. And states are contained in server models. And a server model, it's contained in an element, and each element can have one or several server models. And the elements is what is addressable in a network. The counterpart is the client model. So the client model defines messages. So there's a get message to get the status of the state of the server model. And there's a set message to control it. So you can set it on or off. And in both cases, the server model will return a status message to indicate what the current status is. These messages are short, so they are most of them are contained in one advertising packet, and that means that is actually contributed to reliability and also the speed. So by having just one packet, you have low latency. If you had two packets, you would need to wait for both packets to arrive and reassemble it. So it's also a risk of losing one of the packet. So having just one packet is actually one of the reasons why this network is reliable. And just being short in general avoids interference with other packets. So actually the model, the way the models are implemented is actually a contributor to why the Bluetooth Mesh is such a reliable technology. There's a model specification that defines generic features, models for sensors, time and scenes, and lighting. So to give a bit overview of how this fits together, let's have a look at this diagram, which is from a white paper on connected lighting system from Bluetooth SIG. So let's see some examples here. So there's a light switch, which has a configuration server, which you use to configure it, and a health server, which will publish its current health. So this is how you monitor if your systems are working as they should, or if you need to change the battery, or if it's malfunctioning, and so on. The configuration server and health service, those are foundation models, which is defined in the mesh profile. And then there's a generic on-off client, which is defined in the model spec. So that's why the configuration server and health service, you will see that repeated for all the devices in the network. So generic on-off, that is a product that allows you to switch the lights on and off. You can also implement a slider that uses the generic level client and server, which can be used for dimming. Or if you get more advanced, and this is where you start seeing the value of a wireless solution, instead of just interrupting the power line, you can have scene selector. So a scene can define on-off or dim level or color temperature and so on. And with the scene client, you can do scene recall. So just with one button, you can go from I am working to I want to relax from a button panel. Or you can have a dimmer switch where you can do both light lightness or on off, so you can switch it on and off or decide on the output level. So all these devices can send. You can use that to interact with a luminaire. On this image, there's also a sensor which does occupancy and light level. So this allows you to switch on or increase the light intensity when there is actually people in a room. Or you can use the light level sensing to understand if the room is already lit from sunlight, for example, and then you can control the light output on that based on that information. So this is implemented with the sensor server and the sensor setup server, which allows you to set certain parameter of the sensor itself. In the lighting system, the sensor usually communicates with the controller model, which is kind of a interesting model. It controls light output based on sensor input, and there's actually products in the professional lighting market, which is the lighting control box, which is a separate component, and you typically wire your sensor to that box, and that box calculates the light level, and it sets a dimming to a light source. So with Bluetooth Mesh, and also and this is basically related to the electronics that goes into the luminaires that support the Bluetooth Mesh technology. They are so powerful that this lighting control box is no longer needed. You can do these calculations in the light itself. So you actually eliminate the lighting control box. You do it on a luminaire and you control the light source. And as you see, the light itself is now getting quite advanced. We have the configuration server health service. You can switch it on and off. There are generic models related to how it behaves when you turn on the power. You can set dimming level. You can define scenes. You can set up scenes. And in this example, there's a lightness server and setup server. So that's is a model that defines the light output level. The last thing is the use of a smartphone app. So there's a joke you often hear that you can switch on and off a light with your smartphone, and people make fun of it because it's so impractical compared to just a switch on a wall, and that is true. It is more convenient with the switch, but configuring when it comes to configuration, the smartphone provides a really useful user interface to set up all the configuration parameter for that light. So that's the main value add when you get smartphone connectivity to a light. So you can connect your phone directly to the light source, and you can configure the light as you want in terms of what the output should be, how you should regulate the light, and what type of scenes you want, and so forth. So this brings us to the end of the Bluetooth Mesh introduction part. And as I mentioned, the lighting was an important use case, and I hope you understand why by now. But I also mentioned that was just the beginning to create truly smart buildings. So on illustration on the right, imagine that you have a grid of light nodes which are connected by Bluetooth Mesh. But also think what this gives you. You have a network of devices that has a fixed location. They're probably present in every room in the building, and you have unlimited power. So what can you do with this? So first of all, since this is a Bluetooth radio, you can use that radio for other purposes. For example, positioning technologies. You can do asset tracking by listening to beacon signal from the asset the asset tag that they have in your assets. Or you can actually use the light as beacons themselves to allow positioning through a mobile phone. I mentioned also you use occupancy control to control the lights if they're on and off, but you can also use this information to understand how the building is used, where people move and how they move. You also have predictive maintenance because of the health service. You can know if a device is about to fail, and you can repair it before it fails fully. So it makes it possible to set up a better, more efficient maintenance schedule. We already see project now that includes sensing of temperature and air quality, and this can be combined with HVAC. And there's all the use case, for example, emergency lighting, which has requirement to be tested at the regular schedule. And for building automation in general, there's many use cases that can be covered by the Bluetooth Mesh network. Now, let's talk about the Bluetooth Mesh support in the area of Connect SDK. So this is probably one of the biggest news that we added in the last year. Nordic Connect SDK, that is our unified SDK for the nRF91, the nRF53, and nRF52 series, and for the future products. So the move we have done with the nRF Connect SDK has been successful, and it shows that we can have one SDK that support the whole portfolio, and we currently have all our wireless technologies for Nordic Semiconductor supported by this SDK. It combines source code and tools from Nordic, but also from the open source community and our partners. And I put the Zephyr logo because it's heavily dependent on the Zephyr RTOS and it uses that RTOS and ecosystem extensively. So in this diagram, you see how the different parts fit together. The color coding, if you see it in blue, it's a Nordic implementation and unique to nRF Connect SDK, while the violet parts are code that is implemented in the Zephyr RTOS and that ecosystem. So starting from top with the examples, we provided a set of relevant examples for Bluetooth Mesh. So you should recognize the fixture, the switch, and the sensor from the example I showed earlier when I talked about the models. And there's also a chat example which is made to show how to implement vendor-specific models. So those are models that are not specified by Bluetooth SIG. It's models that you want to implement if you have a use case which is not defined in Bluetooth SIG. And it basically allows you to transmit any type of message that you want. You define it yourself. It's very similar to wireless UART. Nordic provide a complete implementation of the Bluetooth Mesh models and profile specification. The models is implemented by Nordic and only contained in the nRF Connect SDK, while the mesh profile was already part of the Zephyr project, and we decided to work on that implementation and improve it and include it in our SDK. The same decision is done with the Bluetooth host, so that's also part of the Zephyr project. While for the controller, we are going for our rock-solid software controller, which is the controller implementation that we used in our soft devices. I also illustrated how they interface. For normal operation, you see advertising bearer that interfaces directly to the software controller using HCI commands. While the GAT bearer, which is a bearer used for when you connect to a mobile phone, that interface with the Bluetooth host to get the GAT support, which in turn interface to the software controller. I also want to point out that the Zephyr components are maintained in the Zephyr project, but they're actively maintained by Nordic engineers. So we actively contribute to it along with other companies. And we ensure that this has the same level of quality as we are known for in the market. What we provide, in addition to the implementation itself, are rich examples which are suitable for prototyping. They go a long way to integrate things that are hard to integrate, and it gives you a really good starting point when it comes to product development. In our implementation of the mesh profile, we used kconfig, so that's a configuration tool to include the software components, and that allows you to define if your code should support the relay, friend, low power node, provisional role, or GAT features. And this is done by configuration system. So if you decide to support the feature or not, you can do that without coding. Just click if it's going to be supported or not. We also have supported for a long time the Enotion switch. So that's a implementation that can receive messages from the switch that you see on the picture. Those are battery-free energy harvesting switch modules, and they actually take the energy from the push of the button, and that allows you to send a series of 5 messages to a network to control lights. And since it doesn't need battery and you can press it freely, they're quite popular in the industry. And we support it. So this is not Bluetooth Mesh as a technology, but it uses a Bluetooth radio, and that allows us to integrate it. And what we've recently done is also to integrate the Silverware and an Ocean proxy server implementation. So Silverware has their own model definition for the Notion switch that allows you to commission the switches with their tool. It's already being used, and they decided this year to open up the specification, which we're grateful for, and it allows more companies to standardize on the solution and integrate other products to create a larger ecosystem. The last release of the Connect SDK, the version 1.7.1, we finally completed qualification for all the needed components. This slide shows the relevant QDIDs that you need to combine for an end product. The last one to go was the mesh profile, but now you have everything you need to qualify an end product when you design with Bluetooth Mesh. We also offer the NRF Mesh mobile app. So this is a tool to connect to nodes. It can act as a node itself in a network, and it provides all the features to do provisioning and configuration of the nodes. This tool is available for both Android and iOS. And one nice feature is that it implements a configuration database. So when you do provisioning configuration, this is stored in a JSON-based database that follows the Mesh CDP spec, and this is needed for storing your data about the network. The provisioning tool is basically the one that contains all the information, setup information of your network. So this is important data, and by following the spec, it's easy to integrate with other systems. We distribute this as source code, and it's also designed as a library. So the UI is very spec-centric, and if you want to design your own phone app, you're more likely to, or we recommend that you design it for your specific users or your specific industry. This tool is mainly designed to show you what features you have available and how to interact with them. But for the end user, you just take the library and you design your own user interface to fit on top. On this slide, you see the SoCs from Nordic that supports Bluetooth Mesh. So the main criteria why it's these specific parts is the available flash memory. There are some other Nordic parts in 52 series that have 256 kilobytes of flash or less, and that is on the borderline and too little that we can test continuously with our test we're running. So these are parts that we test continuously and guarantee that everything works. That said, the other 52 parts have the same architecture, and the implementation is software only. So it may run, but you're likely to run out of memory. And the success of Bluetooth Mesh shows that customers demand more features, and 52840 is actually quite a popular platform for the technology with 1 megabyte of flash. Another thing to point out here is Bluetooth support. So they all support Bluetooth, but some of them also support 802.15.4, which is the radio for Thread and Zigbee. And in many cases, the customer is considering Bluetooth Mesh, but some customers have legacy products for using Zigbee, or they want to have one platform that supports both Bluetooth Mesh and the Matter protocol, which is based on Thread. And then it's very handy to have a component that combines these protocols, and you can have one radio design that can be used for several product lines. So that is also something to consider. Also, on the 5340, you have a dual-core solution with M33s. The flash and RAM numbers added together into from the two cores. That may also be an advantage in your product. So I want to run up this presentation by saying that Nordic gives you everything you need to build the first Bluetooth Mesh products in terms of features, performance, and qualification. But we have a long road ahead of us. We are continuing investing in this technology with new Bluetooth Mesh features. There are features specified by Bluetooth SIG and value-add features we define ourselves. We'll work on better integration with our software platforms and other features that are relevant in the final products. And we also work on testing and performance to better understand the network technologies and provide you better answers when you, for example, ask how many nodes your network can support. One last thing to ponder upon if you wonder if this is good technology, how important it is. I gathered some numbers. First, related to buildings. So 40%, that is the total energy consumption in our buildings. So that covers both commercial or residential buildings. I got this as an approximate number over the latest years, both from EU countries and the US. But I'm assuming this applies basically to any industrialized countries. But that's quite a lot. Savings, so 70 to 75%. That's a number that was published by Bluetooth SIG, and you can see presentations on the website where they actually talk about this. But that's the savings you get from the use of smart controls. That means the lighting system and the way it's controlled by sensors. That alone gives you 70 to 75% energy reduction. So not all the energy consumption is lighting, but it's a significant part, and lots of the lighting is actually wasted. For example, if you go now in the part of the world where it's a bit dark at night and you walk in the city and see offices at night, you will see them frequently lit up on all floors, and you will see very few people moving around. An important thing about this savings number is that this comes from actual installation. This technology is being installed as we speak, and it's based on true experience. When it comes to value, people in the commercial building market talk about the 300 rule, so that those numbers are in dollar per square foot per year. And the first three, that is related to utilities, so that's $3 per square foot per year. 30 is rent, and 300, that's what you spend on payroll on people actually using the building in a commercial setting. So what this energy saving shows is that the investment pays off quickly. So you gain back the investment in a matter of years. But those savings, those are rated the first number, the 3. When it comes to 30, like rent, that's how much space do you actually need, and 300, how well are the people? That's related to the wellness of the people, or how efficient are people in the building? So with sensors, you can actually learn a lot about how your building is being used and how you can improve it, both for space utilization and the people inside it. So I would argue there's a big need for smart buildings now, and lighting is a really, really good start. And with that, I will thank you for the attention, and we'll move on to the questions.